Good morning, children. Listen, Binomial Theorem sequences and series, Chapter 5. We are learning now exercise 5.1, in which question number 9 from first exercise, page number 210. And now let us recall, revision. Okay, let us revision. First, to learn the first exercise, we need the revision. That is, first one is Binomial Theorem. Binomial Theorem is given by the formula x plus a the whole power n is equal to x plus a the whole power n is equal to nc naught into, listen, nc naught, here power n, so that is why nc naught, nc, which is revision, clearly listen, x plus a the whole power n is equal to nc naught into x power n, first time x power n into a power 0, okay, plus, now combination increasing, nc naught, nc1, nc2, etc., ncn, and x powers are decreasing, x power n minus 1, x power n minus 2, etc., x power n, and a powers are increasing, a power 0, a power 1, a power 2, a power 3, etc., a power n. So which is a binomial theorem. See, now initially, which is revision, okay. Now can you tell me what is nc naught next? Good, very good. That is nc naught, next nc1 into x power n. See, one power we want to reduce. That is x power n minus 1 into a power 0. Next term is a power 1 plus next nc2 into x power n minus 2 into a square, likewise plus etc. Plus etc. Plus the last term is given by ncn. Okay, ncn into x power 0 because x powers are decreasing. Okay, into x power 0 into a power n. So which is binomial theorem. Okay, which is binomial theorem. Now over. Next, the general term t r plus 1 is equal to, the general term t r plus 1 is equal to ncr into x power n minus r into a power r. The general term is given by t r plus 1 is equal to ncr into x power n minus r into a power r. Okay, listen, here that is the coefficient is ncr. The coefficient is ncr. Listen, the coefficient of tr plus 1 is given by ncr. Listen, here r, so that is why here also r. So tr plus 1 coefficient is given by ncr. See, for example, suppose t r plus 1 plus 1. Okay, suppose t r plus 1 means, can you tell me the coefficient? Yes, the coefficient is given by the coefficient. Listen, here suffix, forget plus 1, suffix r means r. Here, forgetting plus 1, here suffix r plus 1. So that is why the coefficient is nc r plus 1. Similar idea. T, suppose t r plus 2 plus 1. Okay. So remember, forget this plus 1. Can you tell me the coefficient? Yes. The coefficient of t r plus 2 plus 1. That is 2 plus 1 equal to 3. This 3 can be rewritten as 2 plus 1. That's all. Okay. Its coefficient is given by nc r plus 2. Likewise. So, okay. Remember some more formulas. Middle term. Okay. Middle term. Middle term, if n is odd. If n is odd, then there are two middle terms. They are t n minus 1 by 2 plus 1 and t n plus 1 by 2. So, by 2 plus 1. If n is odd, then there are two middle terms. They are t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay. And if n is even, then there is only one middle term, which is the middle term is given by t n by 2 plus 1. So again, binomial theorem, general term. And the coefficient of t r plus 1 is given by ncr. Here r means r. Okay, forget plus 1, r means r. Here r plus 1, which means the coefficient is given by, listen, r plus 1, so r plus 1. Here the coefficient of t r plus 2 plus 1 is given by the coefficient, here r plus 2, so that is why here r plus 2. So binomial theorem and the general term, coefficient. We are learning about coefficient, and if there are middle terms, we are talking about the middle terms, the first one, second one, and also we know that ncr is equal to nc n minus r. ncr and nc n minus r equal. Okay, which is formula, very important formula. ncr is equal to nc n minus r. So how we are writing means here first number minus suffix number. Okay, so n fixed, and the first number minus second number, that is suffix number. NCR is equal to NC n minus r. Okay, say for example, can tell me suppose 10C7 equal to 10C7 is equal to 10 minus 7 equal to 3, that is 10C3. Likewise, for example, 5C3 is equal to, yes, 5C3 is equal to 5 minus 3, 2. So 5C2. So these are the revision, okay, revision, which is revision complete. Okay. Children, listen. Here come to the given question. The given question is, if n is positive integer, then show that 9 power n plus 1 minus 9n minus 9 is divisible by 64. Okay, is divisible by 64. And also here the keyword is using binomial theorem. That is important. Here we want to prove this question using binomial theorem. Here the question is available using binomial theorem. Using binomial theorem. So we forget to write using binomial theorem. Again, if n is positive integer, using binomial theorem show that. That is important. So we must use binomial theorem. The question available, the keyword is using binomial theorem, means we have to use binomial theorem only. Okay. If n is positive integer, then using binomial theorem show that 9 power n plus 1 minus 9n minus 9 is divisible by 64. So we want to use, must use binomial theorem. That is very important. Okay. So first of all, for our convenience, take 9 power n plus 1. Okay. Take 9 power n plus 1. Listen the technique. So listen. 9 power n plus 1. Okay. Which is equal to 9 power n plus 1. Now consider the base 9 and divisible by 64. That means divisible by 64 means, for example, 8 square 64. Okay, 8 square is 64. So we want to write in the form of 8. Because of 64, we need where 64 equal to 8 square. So this 9b want to split in the form of 8 plus or 1 plus for our convenience. That is 8 plus. That means 9 equal to 8 plus 1 or 1 plus 8. For our convenience, 9 equal to 1 plus 8. That's all. Why particularly we are splitting 9 equal to 1 plus 8? Because it divisible by 64, where 64 is equal to 8 square. So that is why we are splitting 9 equal to 1 plus 8. Why not 9 equal to 10 minus 1? Yes, here 10 minus 1 means this 64 is not multiples of 10. So that is why we are not writing 9 equal to 10 minus 1. 64 is multiples of 8. So that is why we are splitting 9 equal to 1 plus 8. That is the technique. Okay. According to the situation, we have to split it. Okay. Here 9 power n plus 1, where 9 equal to 1 plus 8 and the power n plus 1 fixed. That's all. First step over. Okay. First step over. Again, power n plus 1 as it is and 9 equal to 1 plus 8. Why particularly we are splitting 9 equal to 1 plus 8 means where 64 is the multiples of 8. So that is why we are using 8, 1 plus 8. Now it is of the form x plus a the whole power n. Okay. X plus a the whole power n. X plus a the whole power n is equal to, just before we do revision, that is x plus a the whole power n is equal to nc naught into x power n into a power 0 plus etc. plus ncn into x power 0 into a power n. Likewise. Okay. Here, first nc naught, where n is equal to n plus 1. Listen, remember, n plus 1 c naught. That's all. Listen, it is of the form where n equal to n plus 1. So by binomial theorem, nc naught into x power n into a power 0. Okay. And one can write here. Listen, here x is equal to 1. Okay, here x is equal to 1 and a is equal to 8 and n is equal to n plus 1. Okay, n is equal to n plus 1. So this things we are using here. Okay? X plus a the whole power n is equal to nc naught into x power n into a power 0 plus nc1 into x power n minus 1 into a power 1 plus etc. Okay. Now listen, it is of the form nc naught into x power n, where n is equal to n plus 1. Listen, nc naught into x power n, that is where n equal to n plus 1. Okay. Into a power 0, that means a power 0. Okay. Listen, nc naught into x power n into a power 0. Now combination increasing and x, these 1 powers are decreasing, 8 powers are increasing. That's all. Okay, can you tell me next term? Yes. N plus 1 C naught. Next one is n plus 1 C1. Okay. Into 1 the whole power. Here, these 1 powers are reducing. X power n minus 1 likewise. Here already power n plus 1. And 1 power we want to less. That means 1 power n plus 1 minus 1 is equal to n. That's all. So n plus 1 power reduce, so power n. Into 8 power 0, next to 8 power 1. 8 power 0 next to 8 power 1. That's all. Okay. Listen, the next term. The next term will be plus of n plus 1 into C2, nc0, nc1, nc2. Likewise. Okay. Into here 1 power n plus 1 power less, so 1 power n. Now 1 power n minus 1, okay, into 8 whole power 2, 8 whole power 2, okay. Next plus etc. Plus etc. plus etc. plus, can you tell me the last term? Yes, last term is ncn into x power 0 into a power n, where n equal to n plus 1. So n plus 1 c n plus 1 into n plus 1 into c n plus 1 into here 1 powers are reducing. So that is why 1 power 0 into 8 powers are increasing. So 8 power n. 8 power n plus 1 because n equal to n plus 1. Okay? Remember n equal to n plus 1. Listen, it is of the form nc0 x power n into a power 0. Okay, nc1 into x power n minus 1. 1 power we want to less. Into a power, that is a power 1, that is 8 power 1. Likewise. Okay. Remember, it is very simple, where n equal to n plus 1. So n plus 1 c0, n plus 1 c1, n plus 1 c2, etc. n plus 1 c n plus 1. Next, 1 power n plus 1. Now 1 power less means 1 power n. 1 power less means 1 power n minus 1, etc. 1 power 0 because reducing. Next, 8 powers are increasing. 8 power 0, 8 power 1, 8 power 2, etc. 8 power n plus 1 because the last term is n plus, where n equal to n plus 1, so that is why n plus 1. That's all. Okay, now I want to simplify. Which is equal to, listen, nc0 tends to 1. nc0 tends to 1. Okay. It is of the form nc0 tends to 1. Next, 1 power anything tends to 1. 1 power any number tends to 1. Next, any number power 0. 8 power 0 tends to 1. Any number power 0 tends to 1. So 1 into 1 into 1, 1. First term is 1, over. Next, I come to here. Here, n plus 1 c1 is equal to n plus 1 c1. You write as it is, no problem. n plus 1 c1, that is n plus 1 c1 is equal to n plus 1. Okay, n plus 1 by 1, that is n plus 1. So n plus 1. n plus 1 c1 equal to n plus 1 by 1 no need, so that is why n plus 1. And here, 1 power any number tends to 1. 8 power 1 equal to 8. So into 8. So second term completed. Come to here. Here, n plus 1 c2. Write as it is. Don't simplify. n plus 1 c2 as it is. n plus 1 c2 as it is. Next, 1 power any number. 1 power anything tends to 1. And 8 square equal to 64. Now we can write 8 square equal to 64. Okay? 8 square equal to 64. Otherwise, one can write 8 square as it is. No problem. Okay, now plus etc. plus. Plus etc. plus. Listen, it is of the form NCN because first number and the suffix number are equal. So that is why NCN tends to 1. It is of the form NCN tends to 1. 1 power 0 tends to 1. Remember that it is 1 into 1 into 8 power n plus 1. So 8 power n plus 1 as it is. 8 power n plus 1 as it is. Okay. Now whose left hand side is 9 power n plus 1. Okay. Up to this correct. Now come to the question. Listen, we are taking the first term 9 power n plus 1. 9 can be rewritten as 1 plus 8 for our convenience because 64 is equal to 8 square. So that is why we are splitting 1 plus 8. Okay. Next, expanding using binomial theorem. Binomial theorem. Over. Next, first term clear. Next, I need 8n. When we are going to get 8n, listen, this 8 going to multiply inside. 8 going to multiply inside, we get 8n plus 8. So this 8n comes left side, we get a minus 8n. Also, here 1 into 8, 8. 8 plus 1, 9. So this 9 comes left side, we get a minus 9. So that is why now I want to simplify. The simplification is very simple. Listen carefully. 9 power n plus 1 is equal to 1 plus 8 into n is equal to 8n. 8 into 1 plus 8. Okay, plus of n plus 1 C2 into 8 square, why not? 8 square plus etc. plus 8 power n plus 1. Okay? Remember the technique. Now 8n comes left side. We get a minus 8n. 8n comes left side, minus 8n. Next, remember here 1 plus 8. Okay? 1 plus 8 equal to 9. So this plus 9 comes left side, becomes minus 9. One idea. And remember, remaining this say one term and say this third term plus etc. the last term. Okay, that only remaining. And also we want to prove divisible by 64. So that is why here 8n comes left side, 1 plus 8 equal to 9, 9 comes left side because of the question. And remaining this 8 square we want to make a multiples of 64. So that is why 8 square equal to 64, no problem. But here, so we want to make multiples of 8, that is 64 I need. So that is why 8 square equal to 64 is ready. Now the last term I want to write in the form of 8 square. So this can be rewritten as 8 square into 8 power n minus 1. If your doubt means simplify, you will get answer. Now remember the technique. Now next step, 9 power n plus 1, 8n comes left side, minus 8n. 8 plus 1, 9, 9 comes left side, minus 9, which is equal to, okay, which is equal to n plus 1 C2 fixed into 8 square as it is, plus etc. Remember, 8 square equal to 64. Okay, first time 8 square equal to 64. And the last time also I need 8 square equal to 64. So that is why plus etc. plus, this can be rewritten as 8 square into 8 power n minus 1. So if you have doubt, 8 power 2, 8 power n minus 1. If the bases are equal, then the powers are added. Okay? See how to add? Yes. Here bases are equal, powers are added. While adding 2 plus n minus 1. That is 2 minus 1 equal to 1. That is a plus 1. So n 2 minus 1 equal to 1. So n plus 1. We are going to get the before step. Okay. Now taking out 8 square common. Okay? Taking out 8 square common, this 8 square commonly comes outside for my convenience, where 8 square equal to 64. Taking out 8 square equal to 64, so which is equal to 64 into bracket. Okay, 64, common. What is remaining? Remaining is given by n plus 1 C2, okay, plus etc. plus 8 square comes outside. And what is remaining? Remaining is 8 power n minus 1, complete the square bracket, whose left hand side is 9 power n plus 1 minus 8n minus 9. Now listen, given question. 9 power n plus 1 minus 8n minus 9 is multiples of 64. Okay, multiples of 64. So therefore, which is divisible by 64? 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 which is divisible by 64. Yes, this portion is divisible by 64. It means what? This right hand side is divisible by 64, means its left hand side answer is divisible by 64. Therefore, 9 power n plus 1 minus 8n minus 9 is divisible by 64. Which implies 9 power n plus 1 minus 8n minus 9 is divisible by 64. Is divisible by 64. So, hence proved. Okay, this sum is completed. Again, to learn this exercise, we need a binomial theorem, very important. Okay, binomial theorem is very important. X plus a the whole power n is equal to nc0 into x power n into a power 0 plus nc1 into x power n minus 1 into a power 1 plus etc. plus ncn into x power 0 into a power n. Okay, so which is the required answer for 9th sum. Children, listen. Now next 10th question from exercise 5.1. The question is, if n is odd positive integer, if n is odd, it is a odd number is very important. If n is odd positive integer, prove that the coefficients of the middle terms in the expansion are equal. Okay, listen again. If n is odd positive integer, prove that the coefficients of the middle terms, in the expansion x plus y the whole power n are equal. So we want to prove the coefficients of the middle terms are equal such that where n is odd number. Okay. Now, first of all, since n is odd positive integer, listen carefully. Solution: since n is odd positive integer, okay, since n is odd positive integer, then there are two middle terms. Okay, therefore the middle terms are t. Can you tell me middle terms? Yes, if n is odd positive integer, then there are two middle terms. The two middle terms are t r minus 1, t not r n. Okay, t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay, so therefore the middle terms are, since n is odd positive integer, therefore the middle terms are Therefore the middle terms are t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay, there are two middle terms. If n is odd positive integer, then there are two middle terms. They are t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay, there are two middle terms. Ready? Now, the coefficients of middle terms. So now I need coefficients. Listen, for example, t r plus 1. T r plus 1 means the coefficient is NCR. Likewise, here forgetting plus 1, the first one coefficient is NC n minus 1 2, n minus 1 by 2. And here the coefficient is given by NC n plus 1 by 2. Okay, therefore the coefficients are remember the technique is very simple. Here n minus 1 by 2. Okay, that is why NC n minus 1 by 2. So which is the one coefficient. Okay, and remember with the technique, say for example, t r plus 1 means NCR. R plus 1 means NCR. Here R means R. N minus 1 by 2 means N minus 1 by 2. So this plus 1, forget. Okay, similar idea. And can you tell me, here the coefficient for t n plus 1 by 2 plus 1 is given by NC. Here n plus 1 by 2. So which comes the suffix. So n plus 1 by 2. That's all. Okay, it is idea. Again, since n is odd positive integer, then there are two middle terms. They are t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Therefore, the coefficients are given by nc n minus 1 by 2 and nc n plus 1 by 2. That's all. Now we want to prove these two coefficients are equal. Okay. Now listen carefully. Preparation is very simple. Now, okay. Now I want to take first one. So let us take first one. Then we want to prove is equal to second one. That's all. Okay. And one can take any one. Suppose taking first one and proving second one. Otherwise, taking second one and proving first one. Both are correct. No problem. Now I want to take this first one. Okay. Remember, listen carefully. nc n minus 1 by 2, which is equal to. We know that NCR is equal to nc n minus r. Using that formula, it is of the form NCR. NCR is equal to nc n minus r. So that is why nc, okay, here r is equal to n minus 1 by 2. So NCR equal to nc n minus r, where n, okay, minus of n minus 1 by 2. That's all. Listen, remember, because the formula is NCR is equal to nc n minus r. That's all. Formula NCR equal to nc n minus r. That is first number n fixed. Okay. Now n fixed. Next, first number minus suffix number comes suffix. That's all. N minus r. So the suffix n minus r. Same idea. First number fixed. And the suffix becomes first number minus the suffix. Yes. First number minus the suffix. Now minus going to multiply inside. Also cross multiply. Cross multiply means you get a 2n. Then minus going to multiply inside. Say first of all 2 cross multiply. So 2n. And the minus going to multiply inside the bracket. Inside the numerator. Okay. So your answer will be, which is equal to nc 2 into n. 2n. Okay. Minus into n, minus n. Minus into minus, plus 1. Fully divided by 2. That's all. Now next step. Next step, 2n minus n equal to 1n. That is n plus 1. So, which is equal to nc n plus 1 by 2. Okay. nc n plus 1 by 2. Whose left hand side is nc n minus 1 by 2. Okay. So, hence proved. That's all. Again. So, we want to prove the coefficients are equal. Yes, we prove the coefficients are equal. So, hence the answer. Okay, hence proved. That's all. So, which is answer for 10th question. Children listen. Now, 11th question from exercise 5.1. The question is, if n is a positive integer, if n is a positive integer and r is a non-negative integer, n is a positive integer and r is a non-negative integer, prove that the coefficients of x power r and x power n minus r in 1 plus x the whole power n are equal. Okay, are equal. Are equal. So which is the question? Are equal. Now solution. Listen carefully. N is a positive integer and r is a non-negative integer. Prove that the coefficients of, listen, remember, the coefficients of x power r and x power n minus r in the expansion 1 plus x the whole power n are equal. So we want to prove the coefficient of x power r is equal to the coefficient of x power n minus r in the expansion 1 plus x the whole power n. That's all. Okay. Now listen. The given expansion is 1 plus x the whole power n. You take first that one. Okay. Given expansion is 1 plus x the whole power n. Okay. 1 plus x the whole power n is comparing with the x plus a the whole power n. That's all. Given question is comparing with the x plus a the whole power n. We get x is equal to 1. Okay. X is equal to 1. Okay. X is equal to 1. And a equal to x. A equal to x. Okay. X is equal to 1. A equal to x. Next n equal to n. N equal to n. And r equal to r. That's all. So which is initial preparation. Okay. Comparing over. And say x plus a the whole power n. For this, we know the general formula. Okay, general term. The general term is given by the formula. The general term. The general term is given by the formula t r plus 1. Okay. The general term t r plus 1 is equal to. General term of x plus a the whole power n is given by t r plus 1 is equal to ncr into x power n minus r into a power r. Okay. General term t r plus 1 is equal to ncr into x power n minus r into a power r, which is formula. Okay, the first line is formula. Okay, general term formula ready. Now I want to substitute. Here t r is equal to r, we told. So r plus 1 is equal to n equal to n, r equal to r. So ncr into x, where x is equal to 1. Okay, x is equal to 1. So 1 the whole power. Listen, x is equal to 1. So 1 the whole power n minus r, n equal to n, r equal to r, into a, where a equal to x. Yes, a equal to x, a equal to x power r. That's all. Now simplification. Simplification, that is t r plus 1 is equal to t r plus 1 is equal to ncr 1 power n minus r. 1 power anything tends to 1. 1 power anything tends to 1. Any number. 1 power any number tends to 1. Next remaining is x power r. Okay, box it, which is the general term. Okay, t r plus 1 is equal to ncr into x power r. Listen the question. The coefficient of x power r. Okay, the coefficient of x power r. It is x power r. The coefficient of x power r is n minus r. Yes. Therefore, the coefficient of x power r is n minus ncr. The coefficient of. The coefficient of x power r is equal to ncr. The coefficient of x power r is ncr. The coefficient of x power r is ncr. Okay, it is idea. Remember the technique. The technique is very simple. The technique is the coefficient of x power r. In this question, here power r, therefore the suffix r. That's idea. Okay, similar idea. Therefore, the coefficient of x power n minus r is equal to nc n minus r. Here power r means suffix r. Here power r, suffix r. Power n minus r, so suffix n minus r. That's idea. Therefore, similarly, the coefficient of x power n minus r. Therefore, the coefficient of x power n minus r is equal to nc n minus r. Remember, here power r, the coefficient is suffix r. Here power n minus 1, therefore the coefficient is here power n minus r, therefore the suffix is n minus r. That's all. So coefficient of x power r is ncr. Coefficient of x power n minus r is nc n minus r. Here n fixed and the suffix, power r, suffix r, power n minus r, suffix n minus r. Now we want to prove the coefficient of x power r is equal to coefficient of x power n minus r. Remember, so these two answers ready. Okay, two answers ready. Suppose it is say first answer, second answer. From these two answers, we know that ncr equal to nc n minus r, which is a familiar formula. ncr is equal to ncr. Okay, ncr equal to ncr. ncr is equal to nc n minus r. Yes, ncr and nc n minus r are equal because it is a formula. Okay, therefore the coefficient of, say, which is a formula, ncr equal to nc n minus r is a formula. Therefore these two are equal. Why not? We can write formula. Okay, formula. From one, say, from these two answers, the RHS are equal because of the formula ncr equal to nc n minus r, which is a formula. Therefore, the coefficient of x power r is equal to the coefficient of x power n minus r. Therefore, the coefficient of x power r is equal to the coefficient of x power n minus r. the coefficient of x power n minus r. Hence proved. Okay, hence proved. Remember, this answer is very simple. 1 plus x the whole power n is comparing with the x plus a the whole power n. Then we are writing general term formula. Then substituting, we get the coefficient of x power r is NCR. Here power r suffix r, that is the technique. Okay, power r suffix r. The coefficient of x power n minus r is here power n minus r, therefore the suffix n minus r. And these two are equal because of the formula. Therefore, the coefficient of x power r is equal to the coefficient of x power n minus r. So, hence proved. That's all. Children, listen. Now, 12th question from exercise 5.1. Question is, if a and b are distinct integers, which means a is not equal to b, prove that a minus b is a factor of a power n minus b power n. A minus b is a factor of a power n minus b power n whenever n is a positive integer. And in bracket there is hint given. Hint is given a power n is equal to a minus b plus b the whole power n. See, the hint, the technique is minus b plus b cancel. And the remaining a power n. Yes, a power n equal to a power n. So that is a hint given. Because of this hint, we must use binomial theorem. Okay. So we want to use binomial theorem. That's all. Now, we want to prove a power n minus b power n is divisible by a minus b. To prove a minus b is a factor of a power n minus b power n, it is enough to prove a power n minus b power n is divisible by a minus b. Okay. That is why I want to prove a power n minus b power n is multiples of a minus b. It is enough to prove a power n minus b power n is a multiples of a minus b. Therefore, a power n minus b power n is divisible by a minus b. That is, a minus b is a factor of a power n minus b power n. So that is a technique. Okay. Now take your given question. That is solution. Given question is a power n minus b power n is equal to a power n minus b power n is equal to here minus b power n fixed. Okay, minus b power n fixed. But a power n only I want to split like this. A minus b plus b. Because minus b plus b cancel, we get a power n equal to a power n. That is the technique. Now listen, which is equal to a power n only I want to fix. I want to split. A minus b plus b square bracket whole power n minus b power n. Remember, minus b power n as it is. And a can be rewritten as a minus b plus b, where minus b plus b cancel, remaining a power n, we get a first term. That's all. Now again, minus b power n as it is. And consider the bracket. This bracket is of the form x plus, listen, x plus a the whole power n. X plus a the whole power n is equal to nc naught into x power n into a power 0 plus etc. plus ncn into x power 0 into a power n is a formula. Okay, binomial theorem we want to use. Okay, which is equal to, listen, which is equal to x plus a the whole power n is equal to nc naught. Yes, nc naught into x power n, where x is equal to a minus b. So nc naught into x power n, that means a minus b whole power n. nc naught into x power n into a power 0, that is b power 0. That's all. nc naught into x power n into a power 0. So binomial theorem we want to keep in the mind that then only we can expand it directly. Okay. Now for my convenience, plus etc. plus etc. plus. Okay. Plus etc. plus. Can tell me the last term. Listen. Remember, the last term is given by nc naught x power n into a power 0, nc1 x power n minus 1 into a power 1, etc. Okay, etc. The last term is ncn. The last term is given by ncn into, here this a minus b powers are reducing. See, power n minus 1, etc. a minus b whole power 0. Okay, powers are reducing. A minus b powers are reducing. And the b powers are increasing. Combination increasing. nc naught, nc1, etc. ncn. and a minus b whole power n, a minus b whole power n minus 1, etc. Reducing. So that is why a minus b whole power 0. Next, b powers are increasing. B power 0, b power 2, b power 3, etc. b power n, etc. b power n. So into b power n. Listen, it is at the form nc naught x power n into a power 0 plus etc. plus ncn into x power 0 into a power n. So keep the binomial theorem, mind itself. Okay. Now for my convenience, can you tell me what is the before term? Can you tell me it's a before term? Yes, 1 power less, that's all. Okay, 1 power less. Which means its before term is given by ncn before ncn minus 1. So that is why I have here place. So its before term is given by n before, that is nc n minus 1. Okay. Here suffix n before suffix n minus 1. Okay. So suffix n before n minus 1. So ncn before ncn minus 1. Okay. A minus b whole power 0. Before is a minus b whole power 1 because reducing. So into a minus b whole power 1. Okay. Into b power n. B power n before b power n minus 1. B power n minus 1. That's all. Okay. Listen again. nc naught into x power n into a power 0 plus etc. nc n minus 1 x power 1 into a power n minus 1 plus ncn into x power 0 into a power n. Formula, but here x is equal to a minus b and a is equal to b. Okay, listen, remember in binomial theorem, here x is equal to a minus b and x is equal to a minus b and a is equal to b and n is equal to n. And the formula we are keeping mind itself. Okay. Remember again, x plus a the whole power n is equal to nc naught into x power n into a power 0 plus etc. nc n minus 1 x power 1 into a power n minus 1 plus ncn x power 0 into a power n, where x is equal to a minus b, a is equal to b. That's all. And also one more idea, combination increasing. Say nc naught, nc1, etc. ncn before ncn minus 1. A minus b whole power n, a minus b whole power n minus 1, etc. A minus b whole power 0, its before term is a minus b whole power 1. See, power 1, power 0, reducing. And the b powers are increasing. B power n minus 1, next b power n. B power n before b power n minus 1, likewise. Okay, up to this ready. Now simplification, which is equal to, listen, nc naught tends to 1 and b power 4, b power 0 tends to 1. nc naught tends to 1, b power 0 tends to 1. What is remaining? A minus b whole power n. Okay. Plus etc. Plus etc. plus. Here, no simplification, write itself. So nc n minus 1 into a minus b whole power 1 into b power n minus 1. Okay, b power n minus 1 over. Next part. Here, can you tell me what is ncn? Good. ncn is equal to, ncn tends to 1. ncn tends to 1. So that is ncn tends to 1. Any number power 0 tends to 1. 1 into b power n, so b power n. Okay, b power n. Now, so the second line, this expansion is expansion for a minus b plus b the whole power n. But the second term, minus b power n fixed. So at last, minus b power n fixed. Okay, minus b power n, that is important. Second term, minus b power n, so minus b power n fixed. The same minus b power n fixed. That's all. Minus b power n, minus b power n fixed. Now any further simplification? Yes. Minus b power n fixed. That is cancel. Okay. Negative and positive cancel. Right, remaining? Yes, remaining. Okay. In remaining, listen, first term, it is the last term, remaining, in which a minus b whole power 1 and it is a minus b whole power n, where a minus b common. Taking out a minus b common, so is equal to a minus b into bracket open. Okay. a minus b into bracket open. Here a minus b comes outside, no problem. And the remaining nc n minus 1 into b power n minus 1 remaining in the last term. But what about in the first term? From a minus b whole power n, we are taking out a minus b. So the remaining will be a minus b whole power. So while the bases are equal and the powers are adding, while adding we get n. So that is why n minus 1, that's all. Verification please. Verification please means here a minus b into a minus b, powers are equal. Okay, sorry, bases are equal, powers are added. So here power 1, here power n minus 1, here power 1 understood. Okay, power 1, power n minus 1, while adding plus 1 minus 1 cancel, we get a minus b whole power n. Plus etc. plus a minus b whole power 1 comes outside. And what is remaining? nc n minus 1 into b power n minus 1. Complete the square bracket, that's all. Now a minus b into a minus b whole power n minus 1 plus 1 minus 1 cancel, we get a power n. And a minus b comes here, we get a before term. And the last b power n minus b power n cancel, already cancel. What is its left hand side? Left hand side is a power n minus b power n. Now listen, a power n minus b power n is multiples of a minus b. So multiple of a minus b. Okay. So which is multiple of a minus b. Therefore, which is divisible by a minus b. Which is divisible by a minus b. So which is divisible by. Which is divisible by a minus b. Therefore, a minus b is a factor of a power n minus b power n. Therefore, a minus b is a factor of a minus b is a factor of a power n minus b power n. So hence the answer. So which is the required answer.